So here are our review problems for today. I'll give you a little bit of a head start.
That one was tricky.
Which one?
The first one, because usually we start with the parentheses, but there's this formula. No, wait, that's right.
Follow your
PANDAS.
PANDAS. And if you'll notice on the first one, there are parentheses around the -4, but those aren't the parentheses we're talking about, remember?
Oh,
If it just says one thing in it, it's
That's
not
right.
really the parentheses we're talking about. It has to have more than one thing in there.
oh, that's right.
I think what we're going to do for the lights is we're going to have somebody put the cardboard that he brought and completely cover up the front tube, and then somehow fix 2 more pieces of cardboard that don't cover, but they hang down on this side. So you guys can use the light, but it won't shine up here. You think? We're just going to cover these up. Have somebody come up and do a better job.
is after the 2, is that a dot before the parentheses?
Yes, this is a times
Okay.
dot. Yes. Yes, after I look at the recording today, we're going to take care of this light reflection situation. See if they can't take care of it over the weekend. And like he said, we may get somebody just take the bulbs out of these front ones. I think we'll do that. And then we just need a hanging down in front of those 2. And I think we will be. Tell me when y'all are through with the first one and maybe the second one so we can get started. Okie dokie. Okay.
so proud of you all.
In a public school, I would give them something like this. And they would visit with each other until I did it for them. Oh, really? When I give them to you, look at this.
We have a great teacher.
Oh. Okay, now one thing I want to look at, I noticed that Irene and Madam, you were still using your phones for your calculations.
Oh, I know.
I need you to use your calculators because there's so many things that you can do with it. This is not a problem if you need to for a last resort. I really want you to get used to our calculator because that's what you get to use on the test. Okay, so let me get you some calculators.
I got one yesterday. I actually got this one yesterday.
Oh, yeah? Good for you. Just mark it out and I'll sign it. Today's the 11th, 9/11. 9/11, remember everybody.
Today is my anniversary, actually.
Happy anniversary.
Birthday and
Yes,
anniversary.
I told my mom, I was like, I'm married on the worst day of history.
How many years?
I got married in 2000. I got married in 2010.
10
So,
years.
10?
10-year anniversary, that's a big one.
It's a long time.
You need to go on a cruise.
I thought we need to go somewhere. So I just find a babysitter.
Did you know my husband and my first anniversary? Okay, here's what we did on our first anniversary. We lived on a farm about 2 hours from Amarillo, 2.5 maybe. My father-in-law needed to go to the dentist. So Stanley and I took my father-in-law to the dentist. He had some teeth cut out or something and wanted McDonald's. And so Stanley and I took him to McDonald's, took him home, 2.5 hours back home, and we went home.
For your anniversary?
That's our first anniversary.
Oh.
The next one I remember is our 8th anniversary. And we were so broke on the farm, really, really broke. And we had just moved into a rental trailer house. And we had been there a year or so. And I bought one of those paper towel holders that is $1.50, you know, and you just screw it under there. Okay. And I kept asking Stanley, would you please put that up? Because it hurts to do this.
Yeah.
You know, and I said, would you put that up? Well, it laid on the counter forever. And I just used paper towel roll, you know, for a year. I came home from school that day and my paper towel holder was put up and he torn off one piece of paper towel and laid it down and said, happy anniversary, honey.
Aww.
And isn't that crazy? These are the ones I remember.
Ah.
And our
That was
25th wedding anniversary, I had just had a life and death operation. And I got home just a little bit before our anniversary. So just coming home was my 25th anniversary. Crazy, huh?
Yeah.
We ended up being married almost 45 years. Yeah, after our 44th one, he passed away in last October. But it was a good marriage. I think marriages are best. You don't have to save something special to wait for your anniversary. He would do special stuff like we would be going on a trip to go get some parts for the combine or something. But we would stop in a store, go to the bathroom maybe, and he would find the perfect little gift and hide it from me until we got back in the car and give me a gift. Or I would come home from school from a particularly hard week and there would be flowers on my pillow and a little card. See, I think anniversaries every day
Yeah.
Right, I need to remind my husband every day. I tell him, I said, just because you know how they are when they first try to talk to you, they give you flowers and there. He's like, what happened to everything? Like, I already got you. I was like, oh, come on, that don't mean nothing. Give me my flowers and
When
stuff.
we were dating, he said, it was time for homecoming because we were dating in college. And I said, you gonna give me a mom? He said, no, they're expensive and flowers die. So I didn't get flowers for years. But my 30th anniversary, he talked to my daughter. He got me 30 roses. 30 roses.
For 30 years.
Took me to a steakhouse here in town and had my daughter bring those roses in and put them on the table. She said all of the couples that were in the booths went, oh, their wives were going,
I would have been one of them.
I would
Why
really
did
like
you
to
do
do
that? That's me.
Oh, that's so cute.
my husband was wonderful. He was great. And I bet you guys have wonderful husbands in Africa.
Oh, he's a keeper.
Good.
I didn't have very good marriages before him. Well, the second marriage. He's my third marriage.
Mm-hmm.
It's embarrassing, but the first one passed away, and then I remarried again, and he was a loser. So I never got married after that until I met him again, and then we ran into each other again in 2014. And this time he said, "You're not getting away."
Yay.
Third time's a charm.
Congratulations. How many years?
We've only been married a year.
Oh, and he's gone.
Uh-huh.
But he'll be home between Thanksgiving and Christmas, right?
Yes, he'll be in the United States October 30th or 31st, but I can't see him till almost the end of November because he has to be in quarantine and then they have to do something else.
Yes. I just got a text yesterday from my oldest son that just landed in El Paso last night from being deployed. And I said, so what are the plans now? And he said, I have to be quarantined for 2 weeks. And then after that, they
It's
have
something called Ron or something
I don't
like
know.
that. I couldn't.
He said there's some more stuff.
Yeah, so it's another 14 days.
And then he said, and then home.
And then, yeah. Where was he at?
Just a minute.
Because Brian said he just barely sent somebody back to the United States.
I will go back and look. I can't remember.
I wonder if they know each other. That would be crazy if they
That
did.
would. That would. He's in the reserves now. He was a Marine, got out for a while in the reserves, and they stationed him. It's been a little less than a year, which is good. And he's coming home.
Yay.
So excited. Okay, let's get back to work. I'd love to know about you all. Irene, I didn't ask you how many years.
Well, mine was 7 years, off and on, and I barely separated like a year and a half, but we're still connecting, you know, like, we get a lot more separated, I guess you could say.
We'll be thinking about you.
Yeah, so, and it's so weird how we were talking about that. I said, you're not the same anymore. It's like, you don't like go out and like say you go out with your friend. You know, you're out about buying this and that. I said, it'll be nice to surprise me. Hey, while I was out, I bought you this, you know, you don't do that anymore. So, it's just like, well, you always complain about it. You always say, is it for somebody else? That's what you're giving it to me. Irene?
We all understand each other, don't we?
Yes.
And that was my answer. You said that's why, because you're always questioning what I
Oh, boo.
do.
Oh.
So it's
Okay,
not-
let's look at the first one. Everybody has an answer?
Yes.
Okay, I'm going to work it out for you unless somebody wants to try.
I know I got it.
Oh, you guys are ducking. Let's try this. Okay, 4 to the third plus 15 divided by 3. This was the one on your worksheet. I just added some more stuff. Minus 2 times -4. Okay. And we're going to use PEMDAS. right?
Yep.
Please excuse my dear Aunt Sally. Remembering that these have the same importance and these have the same importance, left to right. Okay. Here we go, and we know that as we look at these, we're going to only find one answer in each step. This is very important when you're learning how to do this and in the intermediate stage of doing this, so you can start to program your brain to look at one answer at a time. Okay, so we're going to start here. P stands for what? Parentheses. And we found out that although there's a set of parentheses in this problem, these are not the type of parentheses that are talked about here. The reason that we ignore this parentheses is because there's only one thing, one term inside, and so the parentheses are simply used for emphasis. So these are not the parentheses I'm talking about. It has to have more than one term in it. Okay? So in reality, we don't have any parentheses. Okay, so we move down to exponents. Do we have exponents? Yes, we do. And so we're going to underline only that. We're only going to deal with one thing at a time. Eat that elephant, one bite at a time. Okay, now, I'm going to put you on the spot, Rebecca. What does 4 cubed, or 4 to the 3rd power, actually mean that the calculator is doing?
4 times 4 times 4.
Absolutely. 4 times 4 times 4. This tells us how many times this number is going to, this base is going to be multiplied by itself 3 times. Okay, so 4 to the 3rd is 64. 64. So we put the answer underneath what we underlined, and then just write the rest of the problem around it. So we have 15 divided by 3 minus 2 times -4. Okay, our pink is running out. We'll try to get some good ones. All right, and then we look. Now, there is a possibility we're going to stay on exponents because there's a possibility there might be another one. So we need to check for more exponents. Are there?
No.
No more exponents. So we move to multiply or divide, and we're going to start from left to right and do which one we hit first. So which one are we hitting first?
15 divided by 3.
15 divided by 3. And so we have this right here. We don't do any other problems, just this one. 15 divided by 3, of course, is 5. And put the rest of the problem around it. Notice that I use the dot for multiplication, because if I use the X, then when we get into problems that have a variable X in it, we get mixed up. So we're going to get used to using the dot or the asterisk, okay, is how it's typed out when people type it. Okay, again, we're down here to multiply and divide. We've got to check again. And we go left to right until we find another multiply or divide. And I think I see what you all see.
Yes.
Okay, so we're going to multiply. Uh-oh, I bet this doesn't show on the screen. We better do something else. Let's go here. Okay, this is our multiply. And so we only find that answer. 2 times -4 is -8. Then put the rest of the problem around it. Now be careful here. The answer to this is -8. But when we write the rest of the problem, there's a minus. So I need to definitely include this minus as I copy down the rest of the problem. Okay. Now, as we go through here, we're on the multiply and divide. We're going to go left to right. Is there any more multiply or divide?
Yes.
We move down to add and subtract. Okay, so we know that add and subtract are the same importance. And so we work these left to right. We're going to find the first one. And the first one is our 64. that's the one we don't want. A 64 plus 5. Hopefully, y'all, we're going to get a smart board soon. We're working on it. That's that big white board that I can hook to a computer, and we can see some of the problems on there.
I think Clara has
Never heard of that.
Oh, they're next door. There's some in the English room. We had one in here, but I didn't know how to use it yet, so they moved it out. So now I have to fight to get one back in. Anyhow, okay, 64 plus 5 is 69. We only write down one answer at a time and copy down the rest of the problem. Now we have minus a negative 8. And what did we find out when we have minus and negative right next to each other without anything else in between? What do we know about minus and negative? It changes to positive. And so you can either circle it and make it a positive, or you can just make a great big old positive out of it. Two negatives right next to each other are positive. And this is the only operation that we have left. And so we simply add the 69 and the 8 together and get 9 and 8, 77. Am I correct? Those of you with calculators, let's make sure I put the right answer. Are we good? Okay. Any questions on how that was worked? I see some erasing. Did you figure out what?
That last part I did wrong.
This one right here, the minus the negative. So you subtracted, right? Mhm. If you have a subtract, we've got to be careful when we copy down the problem right here, because that in itself was negative. And then there was a minus to copy down. And that is a tricky place. So the answer to this one is 77.
So we minused it?
No, we added. Because two negatives equals a positive.
It had a minus and a negative. And when we have two negatives here, right next to each other, they turn into positive.
Oh, I see that.
So good? And remember, you'll have to speak up because I've got a fan right here in my ear. All right. Ready for the next one? Okay. Okay, parentheses. Can you see this one? I picked up a brown. I didn't realize I did.
This one's tricky. Yeah, I think I did it wrong.
Well, it's probably tricky because I added some stuff in it without working it myself. And so it probably does not come out to a whole number. But
Okay.
I need you to see problems that don't come out to a whole number.
Okay.
Okay. Okay, on this one, we're going to go through our PEMDAS again. The P stands for parentheses. Do we have a set of parentheses?
Yes.
Yes, we do. So that's what we're going to work on. We don't care about the rest of it right now. And this has more than one term in it, so this is the parentheses that we're talking about. 7 plus 80 is going to be 87. And we're going to write the rest of the problem. When we're through there, looking at PEMDAS again, our order of operations, we don't have any more parentheses. We look for exponents next. We have to do our operations in this order. So the E stands for exponents, and of course we have exponents. This base is multiplied by itself 2 times. 4 times 4 is 16. Write the rest of the problem around it. Okay? We're going to find out in this problem that even if it looks weird and it doesn't come out all pretty, that it's still, there are problems in this world that don't come out pretty. Okay? But we always follow exactly the same rules. Okay? So now we look at this and we only have one operation. We don't have any choice here. Now I'm going to have to count on you guys because I don't have a calculator. So these don't show very well. So I've got either 87 divided by 16 to get me a decimal, which you can do on your calculator.
Which is 5.
Tell me.
5.4375.
41.3175.
No,
5.4375.
5.43.
5.43. Yeah. And 5.
75.
775. Okay. This is our decimal. Now, if it's still on your calculator, just push the toggle switch, please.
What's that?
The toggle is right above the enter sign, the enter key. On the bottom,
87
right.
divided by 16.
So this decimal, you can get that on your calculator, and then you hit the toggle switch, and on your calculator, there's the enter key right here, and right above it is a toggle switch, and I think it goes kind of like this or something like that. This is the toggle switch, and it will change your decimal into a fraction in the lowest terms. And if you say, oh yeah, I wanted the decimal, hit the toggle again, and it will toggle right back. Okay?
But it just switched it to 87 over 16. Yeah.
Yes, and that's what I want you to see. 87 over 16, divide and this sign mean the same thing. And because your toggle switch gave you this, you're going to know by looking at your calculator that this is the lowest terms. It won't go down anymore. Your calculator will give you the lowest terms. Try this. In your calculator, do this right now. This is why, Naomi, that I'm really pushing you to use the calculator. Okay, try this one. Okay, put that one in your calculator. Pardon?
15.
Okay, it's going to be 15. Now toggle back. I think it'll probably just say 15.
Yeah.
15.
Okay, let's try another one. I'm trying to get one. Let's go. Here we go. Put that one in. Okay.
1.6666.
Okay, 1.666. So the 6 repeats.
Did I get mine wrong? I got
Now-
5 over 3. 5 over 3.
Yes, toggle back and you will get a fraction that is 5
Over 3.
over 3. Now notice that here was the fraction you started with, and when you put it in the calculator and toggled back, it gave you the lowest terms.
Mine
It
gave me
reduced-
that answer first before the 1666.
It gave you this first.
Uh-huh.
That's okay. It's okay. Did you toggle and get this?
Yes.
Yes. So understand that the toggle switch is your friend, okay? And you can use that over and over again. The main way that you're going to use that is if you do a problem like this and you don't know whether you need a fraction or a decimal, then you look down in your multiple choice and you go, oh man, they're all decimals. So whatever you need to toggle to, you'll need your decimal answer.
Oh, gotcha.
But if down in the multiple choice there's a fraction, then just hit the toggle switch again and it'll give you the fraction in the lowest terms. Do you all see? All right. So
So either one of those answers is correct.
they are exactly the same answers. this one, and this one have the same value. These are just the lowest term fraction, and this is in the form of a decimal. Okay?
Good.
All right. See, Naomi, there's a method to my madness when I make you do something.
And you're correct, because they won't let us have anything in there but their calculators that they give us.
That's correct. And actually, they have a few that they can let you have in there. And there is a calculator on the screen
Oh, yeah.
that you can use.
But that was
I don't know how to
confusing.
use
Yeah,
I need to learn how to use that one.
But they will also, this school here will let you check out a calculator when you're going for your real test. And then you just bring it back after the test. So that would be my suggestion. Because number one, you don't know how many calculators they're going to have for the students. You know, what if they run out? And the ones on the screen are exactly the same, but sometimes it's just not the same as holding on to one. So you can count on being able to check one out here when you're ready for your test, okay? All right, let's go to the next one. Any questions on that last one?
No.
Okay, this one I don't think I messed with, the ceiling. So I have 25 times 2 minus 42 divided by 6 plus 18. Do you need some time or are you ready for me to go?
I already did it.
Okay, good, good,
Yeah.
good, good. So looking at your, please excuse my dear Aunt Sally, your order of operations over here. Do we have parentheses?
No.
Okay. Do we have exponents?
No.
Wow. So multiply and divide, and we start left to right, the first one that we hit.
25 times 2.
25 times 2. So 25 times 2 is 50. Write the rest of the problem down. Then we continue to look and see if we have any more multiply or divide. And yes, we do. The 42 divided by 6. This is very tempting. But don't do the subtract before you come here. Use your PEMDAS. So 42 divided by 6 is 7. Put the rest of the problem around it. We look at it now. I don't see any more add or multiply and divide, so we move down the PEMDAS ladder and we have add and subtract, and we're going to do the one we come to first.
50 minus 7.
And so our 50 minus 7 is going to be 43. Write the rest of the problem around it.
61.
And of course, we only have one more.
Right?
One more operation. So we have 61 for an answer. Did y'all get it?
Yes, ma'am.
100%. Yes, yes,
I
yes.
think the first one was a little bit tricky. But
The first part of it or the first problem?
first part.
The first problem. Yeah, those, when I start messing with them and add stuff into it without working them, you can bet they're going to come out weird.
Mm-hmm.
But weird is good. Weird is good.
But I'm getting it. I'm getting it.
Yay. So you're getting it just in time for us to switch gears.
No.
And D and D and E are equations that we need to solve. Now notice that the first 3 problems that we worked did not have an equal sign. So these aren't called equations.
Oh, you mentioned expression.
Expressions, good job, Irene. These are equations, and usually the instructions that you will have with these equations on the test or anywhere else,
So the expression don't have a equal sign.
that's exactly
And
right.
then the equal sign is
Equation.
equation.
Yes. Now the instructions for one of these will probably just say solve, or it will say solve for the variable, something like that. but that just means you need to get the variable by itself, okay, just like we've been doing. So we're going to, and if you'll notice, I start one sentence and change it. We are going to solve and find out what the variable is like, or what it's equal to, what the value is. If you notice, these problems are almost exactly the same. I did it on purpose because I want to point something out to you, okay? So let's work the first one. And the steps that I've shown you all along do not change. They don't change. So we have 9 b minus 1 equals 63 plus b. And our steps are the way they've always been. Step number 1, put your line down through the equal sign so your brain splits this into 2 sides. And then we circle our variable. Uh-oh. We have them on opposite sides. So one of them's lost. We've got to pull all the b's back together. Now, you cannot pull this b out of here. Okay? So this has to be taken care of before we can get those b's together. And you can look at it like we have to do the parentheses first, okay? We've got to get that taken care of. Since I cannot add b minus 1, I can't put those together because I don't know what b is. So my next choice is to do the distributive property. Notice that there is one number out in front of a set of parentheses. When there is not an operation here, what is it? It's multiply. Multiply, okay? So what we're going to have to do is multiply this 9 times everything that's in the parentheses all the way. If this had 7 or 9 things inside the parentheses before it closed, we would have to take the 9 times every single thing until I got to the closed parentheses. Yes? So I'm going to take the 9 times the first term. And yes, I'm hearing from several that since the b doesn't have anything in front of it, it's a 1b. There's always an invisible 1 hanging around. So 9 times 1 is 9, and it's hooked to a b, so it's 9b now. When I'm through with that one, I write the operation, and then I take 9 times my second term. 9 times 1 is 9 equals, and let's write the rest of the problem. 63 plus b, because there are no more parentheses to take care of. Now, again, the line down through the equal sign, we have it, and we circle our variable. We know we're going to have to deal with this now. There are b's on both sides. I think I'm going to, yeah. There are b's on both sides. Now, you're going to have to get them off of one of the sides. Get them out of the yard. It doesn't matter which one you get rid of, because it will end up being the same answer no matter how you go. I like to get rid of the smaller one. Okay, it really doesn't matter. But let's say I want to get rid of this one so that it will move back over here. So we know that if there's not a number here, there's an invisible 1 again, right? Okay, and if it's plus 1b, and I don't want to separate these two, I want to get rid of the whole thing and bring it over here. So in order to get rid of a plus 1b, I'm going to have to minus 1b. And whatever I do to one side, I have to do to the other side, 1b. Now, when we add straight down, we have 9 b's, and we took away one of them, So now I have 8 B's, and I write down the rest of the problem. I'm adding straight down, equals on the line so we can keep our steps straight. We've got 63, and now I have a positive 1 and a negative 1. 1B is the same with opposite signs, so they zero out. They are additive inverses. They are zero pairs. You're going to hear all those different terms. So now we have our new equation. We're going to go through our steps again, line down through the equal sign, circle the variable. Yay! Whenever you have it just on one side, then things get easier, right? Okay, so now I'm looking at this side. Circling the variable helps me focus on which side I'm going to work with. I'm going to have to get rid of the 8 and the negative 9 so that B can be by itself at the end. So which one do I need to get rid of first? The 9, that's exactly right. Now our little story says that these are so close they're best friends. This is kind of a straggler, and we get rid of the straggler first. So we're going to add 9 because minus 9 and plus 9 are opposite operations. And to balance this equation, before I do anything, I have to add 9 to this side. When I do that, this again is opposite signs but same numbers, so they zero out. Additive inverse, zero pair. So I add straight down. All I have left over here is 8B equals 72. And when I circle my variable, I see that I still have to get rid of the 8. How is the 8 hooked to the B? Times. How are you going to get rid of the 8?
Divide by 8.
Divide by 8. And divide by 8 because we need to balance the equation. And when we do, 8 divided by 8, any number divided by itself is 1. So we end up with 1B here equals 72 divided by 8 is 9. And we know that the 1 is always here, but he likes to be invisible. And so your answer would look like this in the multiple choice. And it sounded like the way you were answering that you guys are doing quite well. You feel good about it? Yes. Now, what I'm going to do is take the same numbers, but they're going to be a little bit different in an equation because I want to show one specific thing to you. Are we through with this?
Yes.
Okay. I'm proud of y'all.
Thank you.
We're a good team.
Yes.
All right. The last one. That doesn't mean I'm through, but this is the last one of these. I'm never through with you, right? Kind of looks like the same problem, a little bit. First step, line down through the equal sign. I've been doing math, teaching it for over 30 years, and then I did the 4 years of college, and I did the 12 years of school, and I still put the line down through the equal sign. Okay? That doesn't mean you're a baby. Okay? You're training your brain. So when we look at this and we circle our variables, we see that one of the variables is stuck inside this barn, inside the parentheses. So we need to take care of the distributive property right away. We know we're going to take 9 times 1b gives us 9b. Put the minus in, and 9 times 1 gives us 9. But we still have a plus b equals 63. Be careful to copy it down exactly the way it is. because this is the part that I wanted to explain to you. When we circle the variables, our line down through the equal sign, and we circle our variables, we can see that sure enough, we have two variables again, and we're going to have to deal with this again. This is just a pain. The thing that is different between this equation and the one before is you will notice that your B's are on the same side. They're in the same yard, which is just fine. We don't have to get rid of any of the B's. All we have to do is group them back up in a group because they're already where they belong. So what we're going to do, these are called common terms, and we'll do a lot more of that when we talk about polynomials later. But these, a B here and a B here, are the same terms, and they're in the same yard. So how many B's do I really have in this side? Here's 9 of them. Here's one more. So I have 10 B's over here. I didn't have to do any balancing or anything. I just grouped them back up where they belong because they're all on the same side. And then minus 9 equals 63. Y'all see the difference between this one and the other one? The other one, they were split into two different yards, and we had to move one back where it belonged. These B's are in the same yard, okay? So all we have to do is get them back in a group, and there's 9 of them here. We've got to go with this one and bring it over into the group, but it's on the same side. So it just becomes 10 B's minus 9, and now it gets easier because you've done quite a few of these already. We're going to circle B, and sure enough, there's only one. And that's when you breathe and you say, I know, I got this. So in order for the B to be by itself, I have to get rid of the 10 and the minus 9. Which one am I going to get rid of first, Rebecca?
The 9.
The 9. It's a minus 9 right now. How am I going to get rid of it? Plus 9. And I have to balance the equation, so I hop over the fence and do the same thing. Now I have 10B, when I add down, equals 72. Yes? And then what do I do next?
You divide by 10.
Good. I'm going to divide by 10 because this is a multiply and the opposite is divide. I have to do it on both sides. And when I do, B, 1B or B, is going to equal either 7.2 or
36 over 5.
say it again, 36 over 5?
36 over 5.
That's exactly right. Or 36 over 5, which is the reduced fraction from here. This was 72 over 10, but it's not simplified. And so we divided the top and the bottom by 2 or used the calculator. 72 divided by 2 is 36 and 10 divided by 2 is 5. And that's how your calculator found this answer or this answer. They are exactly the same value. It just depends on what's in your multiple choice. Are we good? Yay. Any questions? Because we're getting ready to switch gears. And I'm just going to give you an introduction. The next thing that we're going to be doing is mathematical vocabulary. So this will probably be another section in your binder, vocabulary and translating mathematical equations, okay? Translating and vocabulary. Just like I would try to learn Spanish, which I've tried several times and still not very good at it. I had to learn, how do you say desk in Spanish? How do you say chair? How do you say candle? How do you say eat? You know, I had to learn each one of the words by itself, before I could begin to put them together. So that's all we're going to do today is I'm going to give you a list of vocabulary that you're going to be able to refer back to next week when we begin to translate mathematical word problems. Word problems. Okay. Everybody hates them. Hopefully I help you love them. Maybe you'll even say, please give us another word problem. Please, please. Vocabulary. New section, because you'll have some worksheets and notes to go in a new section in your binder. Okay, and this is just going to be a limited list of words and what they mean in math, okay? And that's going to be the end of the lesson today. So just copy these down. The two most used are is, was, and so on and so on. These words, well, I better not do that. These are the words we use for equal. Okay? Is, was, then there's were and are, those type of things. And the other one that's used the most is of. Of.
Of means times, right?
You're right. Of means multiply. And so let's go ahead and put the other one that's confusing out of. When it says out of, it means divide. Okay? Some is an answer to an addition problem. Difference.
Sum is the answer to what?
Addition problem.
Pardon?
Oh, she answered for me.
Differences.
Oh, I was asking sum is the answer to what, and she finished
Oh,
the
okay.
answer.
Difference refers to the answer to subtract, to a subtraction problem. Product. Guess what it's an answer to? Anybody want to guess?
The what, I'm sorry?
Product. It's an answer to a multiplication problem. Quotient. Is an answer to a division problem.
Quotient?
Q-U-O-T-I-E-N-T. It's called quotient, and it's an answer to a division problem. More or more than refers to add. Less and less than refers to subtract. Now this is very important. I'm going to put this trying to stay out of the way here. Now, if we have is more than refers to the sign is more than or is greater. I'll get out of the way here. More or greater than refers to the sign if it has is more than. If it just says 6 more than, then it means add. But if it says is more than, it refers to the sign. And the same thing goes with the less than. If it says is less than, it refers to the sign is less than. Now, also on your notes, I want you to write this. These are called, just these two things are called a switch phrase. Now, just write it in your notes right now because I'll show you how it works later, next week. But these two, the more than and the less than, are called a switch phrase, and you'll understand why when we use it. Okay? Now, let's see. There are some others. Twice. If it says twice, it refers to 2 times. 2 times. Or multiply. Twice means 2 times. There are so many more. These are the main ones that I want you to have so we can begin to look at translating words into mathematics. Okay? When I start to tell you, I'll start to group things together that are in words, in a word problem, and help you understand how to translate these. Word problems hopefully will not be as scary as they have been in the past. Okay? So probably next week will be spent all week translating word problems. And they start you out easy, just like everything else. They'll just give you a little piece that we can translate. Then they put that little piece into a bigger sentence and we can translate. And then it may put it into a paragraph after a while. We'll explain switch phrases. So be sure and be here. You guys are great. Got perfect attendance.
That's what she told me downstairs.
You came all week. Yeah, she told me too. She's like, you be here all week, Corinne. I said, yes. But I'm going to miss only on the 23rd.
23rd,
Yeah.
not the 25th.
No, the 23rd.
Okay, I'll write that down.
25th is mine.
I'm going to need a picture of that again. For some reason, it erased out of my notes, Naomi. So if you'll send it to me again, but I've already talked to him about it.
Yeah. I'll send it to you.
Okay. This is the end of this. I have 3 cute little worksheets that start you out here, and they're kind of cute. And so I'm going to give those to you, but for the rest of the worksheets, I want you to just continue to work on the ones that you already have from this week and ask me any questions, okay? Everybody good?
Yes.
All right.